I do remember clearly that our homework is example 2.1.3, number A. We said we'll go and find the derivative using the definition of a derivative. Those of you who managed to work out example 2.1.3, which was a homework, who managed to work that one out? Vincent, let me start with you, my brother. What did you get as an answer?
I got -3 over x squared.
-3 over x squared. That's your final answer, Vincent?
Yes.
Thank you. As I said, I'm moving in reverse. Now, Tando. My Tando.
Say.
Yes, what did you get?
-3 over x squared.
-3 over x squared. Are you sure?
Yes.
I've got a different answer here. Rio, what did you get, my brother?
So I got -3 over x squared. I know, right? Catastrophe.
Were you sitting together while working out this exercise?
It would seem we were sharing crib notes. Yes. Oh dear.
Yeah, I can see. Hey, and you were sharing things that you were not supposed to share.
Seemingly so. It's a travesty.
Yeah, because this is not what I'm looking for.
Oh dear.
I got -3x to the exponent of -2. So
-3
x to the exponent of -2.
-3x to the power
-2.
So yes.
I'm trying. I'm trying something. I'm trying something here.
I know what he's trying to show that he cheated less. You're a bit too smart for all of us, man. I'm trying something new. Hey, this guy.
Let me thank you all for having worked on this exercise and then having found -3 over x squared or -3x to the power -2. Thank you. Now, let's go to this exercise. Not this one, not this. This one. Use the limit definition of the derivative to find. Use the limit definition of the derivative to find the derivative where the derivative of f of x, the derivative of f, where f of x is equals to 1 over the square root of x plus 5. Any clarity on what I'm asking you to do? Is it clear?
So you are referring to 2.1.4.
No. 2.1.5. Exercise 2.1.5 is what we are working on. This one. This. Oh, Lala.
I see it. Yeah, I see
Okay.
it. Yeah, before I see it. Yeah.
Do you all see it?
It's a question.
Yes, sir. I see it.
Okay, thank you. Tando, do you see it? Vincent?
Yes, sir.
Oh, sorry, sir. I just wanted to find out which question are we working on.
Exercise 2.1.5.
Oh, okay. Thank you, sir.
This one, do you see it?
Yes, sir. Yeah. Thank you.
Please share with us what you got as an answer.
-1
-1
divided by 2 open bracket x plus 5.
-1 all over 2 into x plus 5.
Yes,
Close bracket.
yes,
Is that the end?
yes.
Thank you. We are going in reverse. Okay, this is Tando's answer. Theo,
Yes, sir.
help us out, my brother.
My answer is -1 over 2 multiplied by square root of x plus 5.
-1 all over 2 times the square root of x plus 5.
Yes, sir.
Thank you. Ndumiso,
Yes, sir.
what did you get as an answer, brother?
I got -1 over 2x raised to the power 3 over 2.
-1 all over 2x raised to the power
3 over 2.
positive 3 over 2.
Yes, sir.
Thank you. Abdul.
Yes, sir.
Yes. I'm
Now
here.
I got -1 over 2 square root of x plus 5 cubed.
Sir, I also made a mistake. That's the answer I also got. I was actually taking
Hang
my
on,
words.
hang on.
Yeah.
Hang on, Theo. Hang on. Abdul, let me
Yes,
capture
sir.
Abdul. Let me capture what Abdul is saying first, then I'll come back to you, Theo. Ne?
Okay.
Abdul, you said -1 all over 2 times the square root of x
Plus 5 cubed.
yeah,
So x plus 5 cubed.
x plus 5 cubed inside the square root
Yes.
sign. Or what?
Yes, it's inside. It's under the square root sign.
Inside the square root sign. Okay.
Yes.
Now let me read it to you, Abdul. -1 all over 2. Inside the square root sign, we have got x plus 5 to the power 3.
Correct.
Thank you. Theo?
Yes, sir.
Yes. Now I'm with you.
Okay, so I had made an arithmetic error, silly mistake, but I see it. But yes, my answer is also -1 over 2 times.
Yes, hang on. As an answer,
Yes,
you
sir.
gave me your answer as -1 over 2 times the square root of x plus 5. Are you
Yes.
changing this answer?
Yes, it should be x plus 5 cubed.
X all inside the square root sign.
Yes, it's all inside the square root sign.
X plus 5 to the power 3.
Yes.
Okay. I changed that. Spusiso.
Sir, I got the same answer, but I simplified it even further.
Hang on. Now, if you are saying you've got this same answer here, I'm having Abdul's answer, which is similar to that one of Theo. Ndumiso's answer is different from them.
The Theo and Abdul ones.
answer. Sorry?
Theo and Abdul's answer said the -1 all over 2 the square root of x plus 5 to cube. That answer, sir.
Is that what you got?
Yes, sir, but I simplified it, sir, so but that's what I got. Yeah, I went further. And I said -1 all over 2x plus 10 to the square root of 5x plus 5, because the square root of cubed, or the square root of x plus 5 cubed can be separated to the square root of x plus 5 squared times the square root of x plus 5. Then the square root of x plus 5 squared is just x plus 5. Then x plus 5 times 2 is 2x plus 10. And yeah, so
I think I hear you. That means from my side, I didn't capture what I was told to capture correctly. Okay. Please help me. Sbusiso, Theo, Abdul, help me out here.
yes.
That means what you said -1 all over 2. And then we have a square root sign. Inside the square root sign, that means we have got open bracket, x plus
Yes.
5 to the power 3, close bracket
Yes,
to the
sir.
power 3.
Exactly, sir. No,
Oh.
sir, no. We have
No.
open bracket x plus 5, close bracket to the power 3.
Yes, that is what I mean. That is what I meant.
Oh yeah, yes, sir.
Okay. Abdul, is that what you meant?
Yes, sir.
Theo, is that what you meant?
Yes, sir.
Thank you. Now let's talk to Ndumiso. Ndumiso,
Yes, sir.
your answer is -1 all over 2x to the power 3 over 2.
Yes, sir.
Please share with us how you arrived at this answer.
I can see it's incorrect because I was supposed to use the chain rule, sir.
We haven't yet spoken about the chain rule. I've never mentioned the word chain rule. This year, since I met you, I've never mentioned that.
Yeah, the way I'm seeing it, sir, at the bottom we'll have 1. Okay, we'll have in the numerator 1, and then in the denominator we'll have x plus 5 raised to the power 1 over 2. And then we take that into the numerator, then we'll have open bracket x plus 5 raised to the power -1 over 2. And then I brought -1 over 2 to the front. Then I multiplied it. So now I have -1 over 2 multiplied by open bracket x plus 5, all raised to the power -3 over 2. Multiply the derivative of x plus 5, which is just going to be 1. And then when I multiply together, then my new answer is going to be -1 over open bracket x plus 5, all raised to the power 3 over 2.
Are you done, Ndumiso?
Yes, sir.
I got lost in the
Sir, I
process.
just joined in. We are on question what?
Exercise 2.1.5. Who's talking?
It's Bongani.
Yes, Bongan. Welcome, brother.
Yes,
Ndumiso,
yes.
I got lost in the process, my brother. Did anyone follow Ndumiso?
I
Okay.
didn't, sir.
Theo, did you? Thank you, Spuso. Theo, did you follow Ndumiso?
Not quite, sir.
Abdul, did
So
you
the
follow
the
Ndumiso?
mouse is hiding something there.
Sorry?
The case, I think it's hiding something there on that axis. On the, is it the one there
Yeah, this is a 1.
on top? Okay.
Yes. Abdul,
Hey, so to be honest, I'm not sure. I'm a bit lost as well.
I'm lost. Now, let me... Theo, did I speak to you? I think you're
Yes,
the
you
one I
have, sir.
spoke to.
Yes.
Did I speak to you about Ndumiso's explanation?
Yes, you did. You asked if we follow, and then I said, I'm a bit lost as well.
Oh, okay. Sibusiso, did I talk to you?
I was the first to talk, and
You're
I
the
said
first to
no.
talk.
Yes.
Oh, okay. Thank you. Abdul,
Yes, sir.
do you follow our brother's explanation?
It's also a bit confusing, sir.
May we please, all of us, listen attentively? Maybe. Tando, I'm still going to come back to you, but now let me ask this question to you. Did you follow our brother's explanation?
Yes, I was listening, sir.
Did you follow?
Yeah, the explanation I followed, but I didn't get the answer. The way how
Okay.
he explained, yeah, he was explaining
Okay.
what he wrote, so I heard what he wrote.
All right. May we please, just for the last time, listen attentively to Ndumiso's explanation so that we can, if there is a need for us to can be able to come in, and then so that we can be able to come in and help where necessary. I'm not saying what Ndumiso found is actually not what we are looking for. That is not what I'm saying. Please, let's all pay attention to Ndumiso's explanation. Ndumiso, please go ahead, my brother.
Okay, so I rewrote that question as 1 over open bracket x plus 5 raised to the power 1 over 2. And then so that I could simplify it even further, I rewrote it as open bracket x plus 5 closed bracket all raised to the power negative 1 over 2. So from there, I brought the negative 1 over 2 to the front. So then I had negative 1 over 2, open bracket x plus 5, all raised to the power negative 1 over 2 minus 2 over 2. And then multiplied by the derivative of open bracket x plus 5, close bracket. And then in my answer now I have negative 1 over 2 multiplied by open bracket x plus 5 close bracket all raised to the power negative 3 over 2 multiplied by 1 plus 0, which is just 1. And then my final answer is negative 1 all over 2 multiplied by open bracket x plus 5 raised to the power 3 over 2.
I hear you,
Okay.
sir, but it's not complete.
Yes, I
I
think
hear
that's
you, it's
correct.
not complete. It's not complete.
It's not complete.
Yes. So that 3 over 2, you need to do something with it. remember you converted that your square root into 1/2. So why don't you convert back into the square root as well by removing the 1/2 so that you remain with 3, and then you'll have square root of x plus 5 raised to the power 3. Do you hear me, Ndumiso?
Oh, yes, I see, yes, I see. Yes, I see, okay.
So say his method also works. So it's just that he's not using first principles.
Abdul, I'm listening.
Yes, so he's not using first principles. He used a different method, which is, I'd say, way shorter when it comes to computation compared to the steps we follow when we working or deriving from first principles. So if anything, and not to confuse anyone, but I would advise colleagues, unless stated to say that derive from first principles, we can use Ndumiso's method. If we are not told to derive from first principles, but if we are told to derive from first principles, we'll have to use that formula that we've been using of f of x plus h minus f of x over h.
Let me ask this question. Are we all aware of which formula to use?
Yes, sir.
Yes, we are, sir.
Sorry, sir, may I ask a question?
Yes, Ndumiso.
Or were we supposed to derive using the first principle?
F of f into x plus h minus f of x all over h.
Oh, sorry, sir, I just kind of jumped into it.
Sorry?
Oh, I didn't know. I'm saying I just kind of jumped into it. I didn't know that we were deriving using the first principle. Oh, sorry. It's not bad.
I don't want to mislead other people. Let me confirm with them whether what I'm saying is actually what we are supposed to use or not. Anyone, do we agree that we need to use f into x plus h minus f of x all over h?
We
Yes,
agree, sir.
So now in this instance, I'll say it is not stated from first principles. So for the mere fact that it was not stated to derive from first principles, you could use any derivative formula or method that you have. The only time that I would say
It is
I'm
stated.
more aware or know is that if they tell you, you must derive from first principles. So nothing about the question said you can derive about from first principles. So there's nothing that Ndumiso has done wrong, in my own opinion.
It is stated. It is stated. They say they use the limit definition of the derivative to find the derivative of f of x, where f of x is equal to 1 all over the square root of x plus 5. It is stated that the limit definition is the first principle.
Okay, if you say that, then I guess it is the school that was a problematic, because in most cases they'll tell you from first principles, that's what we normally go for. So if limit definition also means first principles, then it's okay, I understand.
Okay. Ndumiso?
Yes, sir.
Brother. Is there now light there in this dark road that we are traveling on?
Yeah, no, I'm very much found. Thank you, sir.
Okay. Now let's talk to our sister. Tando. Tando, way.
Hello, sir.
Wait, Tando.
Hello, sir.
You got -1 all over 2 into x plus 5. How did you arrive at this answer, my sister?
Say this one, I just guessed.
Tando, I'm disappointed. You can just guess.
No,
No,
I
you
tried to
can't.
use, to use that one for limit of what, but it was too long. Oh, I tried
Yeah.
to do it like in the Mrs. way, but I got
Hmm.
lost.
That's the way. That's the way.
It was too much. Oh, more than 5 minutes. So I thought maybe I'm using the wrong method.
That's the way. That's the road to take. That is the road that will deliver us from Egypt.
Yeah, I'll try.
That is the road that will get us out of this country of the Egyptians. Now, let me I think I've spoken to all those people who have responded to this question. Now, let's get going. There is another theorem. Okay, we're going to talk about it. This is the theorem. Theorem 2.1.1. In this theorem, they are saying differentiability implies continuity. They are saying let f of x be a function and a be an element in its domain. If f of x is differentiable at a, then f is continuous at a. Let f of x be a function and a be an element in its domain. If f of x is differentiable at a, then f is continuous at a. Can we all see this theorem?
Yes, sir.
Even if you don't understand its implication, its application now, the following examples will shed light on how it is applied. If the answer is yes, now let's go to example. Let's look at this example. Example 2.1.5. They're saying find the second derivative of f of x, which is equals to 2x squared minus 3x plus 1. Now they say find f double prime. That means say f prime of x first derivative. If there are 2, second derivative. If there are 3, 4, fourth derivative. Just like that. Now, first derivative of 2x squared minus 3x plus 1. That's where we start. We first have to find the derivative of 2x squared minus 3x plus 1. And then after that, it is then that we can find the second derivative from the first derivative. Now, Tando.
Hello, sir.
Yes. You have no choice.
Yes.
Now we have to find, to use that formula now to find the first derivative. Okay.
Yes.
Now we are applying that formula, f into x plus h minus f of x all over h. it is going to be 2 into x plus h squared minus 3 into x plus h plus 1, close bracket. Then minus f of x, which is just 2x squared minus 3x plus 1, all over h. Clear to everybody? This
Yes.
line?
Yes.
Is everybody happy on this line?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you. Then from there, after simplifying, we end up having 4xh plus h squared minus 3h all over h. Taking h out as a common factor, the h in the numerator and in the denominator will cancel out. Then we'll end up having 4x plus h minus 3. Now, as h tends to 0, we end up having 4x minus 3. That's the first derivative. Now, the second derivative with respect to x will end up having 4. This is how it is found. We take the 4, the way we did over there. We take 4 into x plus h minus 3 minus into f of x. Our f of x in this case is 4x minus 3 all over h. When we simplify and we let h to be 0, we end up having 4.
So I'm gonna ask a question.
Yes, dear.
So what basically is happening here is that if we are finding the second derivative, let's say, what we basically do is we derive the question twice using the limit formula.
Yes.
Yeah. Okay. That's gonna take a while. Okay.
No, Theo. Remember, okay, someone is talking to me. Please hang on. Don't go away. I'll be with you. Theo, remember, this formula, we started using it from high school. Do you still remember it?
Yes, I know. Yeah, and again, I mean, the logic makes a lot of sense. I get it. It's just that it's just the thought in the background that if you're gonna have to derive the sum twice, you're gonna have to do this thing twice. It's not hard. It's just gonna be quite lengthy to do.
Oh, okay.
Yeah, because I mean, for interest's sake, if they gave us this 2x squared minus 3x plus 1, and they said find the third derivative, so that literally means we'd have to apply this formula 3 times. Okay.
But we can also use the power rule.
Yeah, I was about to ask, can we use the power rule or any other way? Because those ones are going to be way quicker than doing it this way.
Unless they take 2.
Abdul, someone was two people. I had 2 people talking.
Are you calling me, sir?
I'm saying.
Okay, in that order. Busiso and Abdul.
Oh, Busiso first. Okay, I was saying we can only use the power rule if stated to. So if we are told to use the first principle, we have no choice but to use the first principle. You can't run to the power rule.
I hear you, man. I hear you. Thank you.
It's a pain. But
yes,
but the third derivative of the function you're looking at 0, because the derivative of a constant is 0, so we don't have the third.
I know. I was just making an example. If we had a situation where we did have a third derivative, basically.
Yeah.
Cool. Thanks. Oh boy.
Thanks, Theo and Busiso. Abdul, your turn now.
Yes, sir. Now, what am I supposed to be doing, sir?
I don't know. You needed to say something, so then I said in that order. Then I allowed Busiso. Sorry?
It wasn't me. I came in because you called me, sir. You called my name. So now I wasn't saying anything at all, sir.
Okay. Thank you. Abdul,
Yes,
now
sir.
that I called you, and then according to you, I accidentally called you. Now, please tell our sister Tando that when mentioned, we have no other way but to use this formula.
Yes, Sister Tando. So unless stated otherwise, I would say always derive using first principles unless you are told to do otherwise. Are we clear, Tando?
Okay, yeah, it's clear. Thank you so much.
Rapsha.
Thank you. Thank you, Abdul. Thank you, Tando. Now let's go to exercise 2.1.5. Where is that? Exercise 2.1.5. Aha. Here is the exercise. S of t is equals to t cubed. Find A of t. Is this making sense before I waste your time or we waste time?
Sir,
It's not making sense. Aye.
Sorry?
It's not making sense to me
sense.
too.
sir,
Yes.
Sir,
Hello.
does
is
the
this
S
a- is this a speed and acceleration question?
Who's talking? Who's talking about acceleration?
Oh, okay. Aye. It makes sense. It
Hey,
makes sense.
princess.
It makes sense. It makes sense.
Eh?
I
Hey,
think it makes
actually,
sense now.
the speed and acceleration.
Is it
I
making
think-
sense?
For me, say it makes sense. Is it? Can I share say something with
Please
the colleagues?
share.
Yeah, hang on. Before you share, Abdul, there is my sister. I can hear that is a sister. Your name, ma'am?
It's me, sir. It's princess.
Oh, Princess. How are you?
I'm well, thanks. How are you, sir?
Good. Oh, are you saying it does make sense? Oh, okay.
No comment.
Okay. Hang on, Princess Abdul. The stage is yours.
Okay, so in this case, since we are working with speed and all these things, so the first derivative of speed will give you velocity, I believe. And
Agreed.
then once you differentiate that velocity, it gives you acceleration. So in simple terms, it's more like find the second derivative of the equation we are given. So yeah, that's it, sir.
Do they follow you?
Thank you. Thank you.
Abdul,
Yes, sir.
I heard your explanation. Do they follow? Please ask them.
I'm seeing the thumbs up, but thank you. So I believe that they follow.
Okay, so now, if that is the case,
Oh,
then
so the
they can.
acceleration is the second derivative.
Yes.
So
Okay.
using the first principle.
So the first derivative give us what?
Velocity.
I'm asking if
Oh,
we're still
okay.
supposed to use the first
Understood.
Yeah, okay, well, to be here it's not stated, say, but looking at the previous example, we'll have to do it from the first principles, guys. Looking at the previous example. So let's just do it from the first principles.
Okay, thank you.
Thank you.
Lerato.
Hey, my brother, how are you?
I'm fine.
Good. We are working on exercise 2.1.5. Ne?
Yes.
Did you get the explanation from?
Yes, I got it.
Oh, okay.
Yes, sir.
Yeah.
The
Lerato, then whoever who's calling Lerato, hang on. Who's calling me?
Vincent.
Vincent will follow. Okay, let's Lerato. After that, it will be Vincent.
Sir, on the question
Yes.
that you asked of 3 over x, what was the answer that they found?
The one which was homework.
Yes.
Okay. Before we share that answer with you, please share yours with us. We have got it here.
It's 3 over x squared.
What?
It's 3 over x squared. I don't know how.
-3.
It's negative.
Hmm.
Ish.
Oh, what do you think?
Yeah, I got positive.
Everybody got -3.
It's fine, sir. I'll check it.
Okay. Thanks.
Sir,
Yes, Vincent.
can that person explain again on that velocity? I'm not sure who was it.
Okay. Abdul,
Yes, Vincent. Well, what you need clarity on?
See, do we need to use the formula of velocity or what? I don't understand.
Okay, in this particular, everything is still the same. What has changed is the notation in which they represented this thing. So I would say, look at it maybe if they had said f of x in the space of st, you could think of it as f of x, and then that t cubed, you can see it as x cubed. So where there will be x, you will substitute x plus h.
Oh, okay, I see. Thanks.
okay.
Sir,
Yes, Lerato.
is it fine if you used what's this thing? Addition of cubes to expand.
If you use what, Lerato?
Like this thing called addition of cubes, whatsoever it's called.
Okay. I don't know what you are referring to, but let me, maybe in what I'm about to say, that will also be part of trying to answer your question. Then, Lerado.
Yes.
Then, while using that formula that I just shared with you, né?
Yes.
Those that I've mentioned, those components of the formula will take the cubed. And then minus f of x, which will also take the cube. I think I've given an answer by saying that.
Yes, I understand. What I wanted to know was for that bracket to the power 3, you put 3 brackets. That's what I wanted to know.
X to the power, is bracket to the power 3.
Yes.
It's not plus 3, it's brackets to the power 3. In fact, it's not brackets, it's brackets.
That bracket to the power 3. Is it fine if you make 3 brackets and expand there?
That is what you are ideally supposed to do.
Okay, it's fine.
In order to simplify.
So,
For you to can be, because we have to simplify. For one to can be able to simplify, that one needs to do those, to do exactly what you just said. Lerado?
Yes, I
Have I,
understand.
have I helped?
Was that? Yes, you have helped to verify.
Okay. Princess, what did you get?
The final answer is 60.
What?
60. The second derivative, which is the
T.
A at T. Yes.
A at T, A of T, you found it to be 6T.
Yes, sir.
Okay. Please talk to them. I heard you. Please talk to them.
Yes, I also found 60.
Yeah.
Agree.
Bongani found
This one-
60.
Agree.
Who didn't find 60?
The final answer. The final answer.
Yes.
After deriving twice,
Yes.
Yes.
you got 16.
6T.
Oh, 60, not 16. I agree, 60.
Do you agree, Lorado?
With 60, not 16. 60, I agree.
Yes, 6T.
I agree.
Princess, is there any disagreement from anyone?
Did we all get 60?
Yes, ma'am.
We agree, colleagues.
Okay. Thank you.
Princess,
Yes, sir.
I don't know how you arrived at the 6T. I'm lost. I hear them. All of them seem to agree with you, but it looks like
Okay.
I'm the only one lost.
Okay. So I used the first principle, T plus H. I used the first principle, say
I'm
f of
listening.
x, S of t is equals to T plus H cube minus T cube over H, which gave us the limit as H goes to 0. T plus H open bracket T plus H close bracket, open bracket T squared plus 2TH plus H squared close bracket minus T cube over H. And then the T cubes, they canceled each other. And then I was left with 2T squared H plus 2TH squared plus HT squared plus 2TH squared plus H3 squared. And then I took out H, which canceled the bottom H. This one is for the first derivative. And they all canceled each other until I was left with 3T squared. And then the second one took 3T squared and plugged it into the first principle. And I had 3 open bracket T squared plus 2TH plus H squared minus T squared over H, which was equals to the limit as H goes to 0, T squared plus 6TH minus 3H squared minus T squared over H. And then what cancelled there? I didn't, let me see. Oh, minus T squared, 3T squared minus 2T squared gave us 2T squared plus 6TH plus 3H squared over H, and then isolated the H, and I got 6T. Yes, everything went to 0.
Okay. Thank you. Princess, what you need to know is that I'm learning from you. I don't know these things that you are doing. That's
Yes,
why
sir.
I asked you for. That's why I asked for the explanation, because I don't know these things. Now you taught me how these things are worked out. Thank you.
Thank you, sir.
Now, Thank you all for attempting this exercise. Now, let's go to another exercise. Aha, here we are. But let's say we will not, we'll see how many we do, depending on whether you are getting the answers that we are looking for or not. If you are not getting the answers that we are looking for, that would mean that we will have to spend a little more minutes on this. But if you are getting the what we are actually looking for, that would mean that no, we must just move on. Okay, so let's look at this exercise 2.1e.1. They are saying, for the following functions, use the definition of a derivative. Definition of a derivative to find the derivative of x. You may use derivative rules. Will be learned in the next section to check if your answer is correct. But for now, use the definition of a derivative to find the derivative. Is it clear what I'm asking you to do in this section? Not referring to any particular question.
Yes.
Just this line. Is it making sense to everybody?
Yes.
No, can it be explained to me?
It's not. It's not.
It's not.
Can you
Is there
explain?
any-
Can you elaborate?
For the following functions, use the definition of a derivative to find the derivative of x. You may use the derivative rules, which will be learned in the next section. But now, for now, let me ask you to not focus on the next line, which says you may use. Let's now focus on for the following functions. For the following functions, use the definition of the derivative to find the derivative of f at x. Now,
Yes, the part that says the definition of the derivative. That's what you want to know. Is it the first principle? That's the definition. Oh, yeah.
who's talking? Is it Bongani?
Yes, it's Bongan.
Thank you, Bongani. I don't know. Remember, I'm also here to learn. Please
Yes.
talk to them.
Yes. Can you please explain the derivative of the? Yeah, the definition of the derivative.
Bongani.
Yes.
The definition of a derivative, it's the first principle. You remember on Monday, when Sir introduced the topic, he said a derivative is defined as, and then he spoke that formula for the first principle.
Oh, okay. I
Yeah.
get it.
Do you remember that formula, Bongani?
Yes, I remember that formula. Yes.
Thank you. Now, let's start with number one. Number one, who should I ask? Tando, how many minutes should we spend on number one?
2 minutes.
2 minutes. Thank you. You have got the 2 minutes. Let me start with you, my brother, Bongani. What did you get?
Yes.
For number
I got
one.
0.
Yes. You got what?
0.
Sure. Ha. Ha, 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 ha. Ah, yeah. Hallelujah.
I didn't get anything. 0.
Yo. Please talk to them, Bongani.
Did you get the same answer, guys?
Yes.
I got 0
Yes.
too.
0/h.
Yeah, they call it got zeros.
They got 0.
Yeah, they got nothing.
Oh, they got nothing. Okay. Thank you, everybody, for having found nothing. That is what we were looking for. Now, let's please work out number 2. And now, who should I go to? Let me go to Theo. Theo, how many minutes for doing number 2?
3 minutes to be fair.
Okay, you've got 3 minutes. Let me start with Princess. Princess, what did you get? Okay,
I
let me
got
do
1.
this. Whoa, hang on. Princess,
Yes, sir.
whatever that you found, ne?
Yes.
You and Vincent talk to each other. I'm pairing you and Vincent. Whatever that you found, please tell Vincent. And then as Vincent will also tell you what he got. We'll take it from there.
Vincent, I got 1.
I got -3.
Now
How
the two of
did you
you
get-
need to talk.
How did you get -3?
I use f into x plus h minus fx over h. Then- So it was
Okay.
2 minus 3x. So I said 2 minus 3 into x plus h minus brackets 2 minus 3x over h.
Okay.
And then when I calculate, 2 will cancel -2 and minus 3x will cancel plus 3x. I'm going to be left with minus 3h over h.
Okay.
Which h will cancel 0.
Nice. Nice. Okay, I agree with you. It seems like I made a mistake here. I didn't cancel.
Okay.
Mhm.
So the two of you, what are you agreeing on?
We are agreeing on -3.
-3.
Since you two are agreeing on -3, please talk to the others to hear whether they are in agreement or in disagreement with what you are telling us.
Whoever got -3 is a genius. Steam and tools.
Yes, -3 is
Whoever
correct.
got -3 is a genius.
Okay, Sbusiso, can I assume that the statement that was mentioned by Sbusiso applies to everybody? In other words,
Yes.
did everybody get -3?
Yes,
Yes,
sir.
yes.
Yes.
Alvin, did you also get -3?
Yes, sir. I also got -3.
Lerato, you are quiet. What did you get, my brother?
-3.
Are you sure?
Yes.
Oh, okay. Now, Vincent. Okay, let me say,
Yes, sir.
Princess and Vincent. Let me thank you for having found an answer for us. Thank you.
Thank you, sir.
Yes, sir.
Thanks, Vincent. Now let me talk to you. We are now
Okay.
about to work out number 3. Do you see number 3?
Yes, sir.
How many minutes should we give everybody to work out number 3?
10
How many
seconds.
minutes?
3 minutes.
3 minutes. Okay, everybody, all of you, you've got
Sbusiso
3
is
minutes.
done.
Sbusiso is that? Okay, thank you, Sbusiso.
Bongani
Jonas was
done.
done.
Hang on, people. Sbusiso and I heard Bongani,
Tando.
Ndumiso, Tando,
Lerato.
Lerato.
Show question 5.
Theo's done.
Theo. Lerato, you want me to show question 5? Okay.
Yes, you can see properly.
Oh, you want to see it? Okay. Any two people to pair themselves and tell us their answer. For number 3.
I vote to be the
Ndumiso,
third
sir.
person.
Sorry?
It's Sbusiso and Ndumiso.
Sbusiso and Ndumiso. Okay? Sbusiso,
Ndumiso,
what
what's
is
your
your answer? Yes, talk to him.
I'm talking to Ndumiso. Sir.
Yes.
Sure, speak.
Ndumiso, what's your answer?
Yeah, I got 2/7.
2/7. Say we agree, me and Ndumiso. We got 2/7.
Thank you, Sbusiso and Ndumiso. Please talk to them.
Colleagues,
I also got
anyone who
2/7.
agrees
I agree.
with us
Both
is a
agrees.
genius.
I agree.
Yes,
I
we
agree.
Anyone who disagrees with
No,
2 over
say we
7?
have geniuses here.
Okay. Now, who should I ask? Princess. You know this, Princess, why are you hiding?
I'm not hiding. I'm very comfortable here.
But I'm not comfortable where I am. Now, we are now doing number 4, yeah?
Yes, sir.
Okay, let me just do this. I'll just do this. Then I'll be guided by you. Guided by you in your majority. If you say to me, then you are okay with these exercises. You can be able to handle them. I should continue, then I will do so. Okay?
Yes, sir.
But for now, until I get that indication, that means we'll continue with these exercises. Now, let's work out number 4. This number 4, Princess, how many minutes should we spend on this number 4?
2 minutes.
2 minutes. Everybody, you heard Princess, 2 minutes. Thank you, Princess.
Thank you, sir.
Lerado.
Sbusiso.
Sbusiso. Ndumiso.
Theo's done.
Theo. People, is
Princess
Elvin
is done.
Who? Princess?
Yes.
Princess.
I'm done, sir.
Please call Elvin.
Hey, Elvin.
I'm here.
I can't hear you.
Can you hear me?
How are you, my brother?
I'm good, thanks. And you?
I'm good, thanks. How far are you?
I'm finished.
You're
I've just
finished. Okay, he's done, sir.
But why didn't he say so?
Because I just about finished, sir.
Okay. Then, if that is the case, Elvin, oh no, yeah, Elvin, pair yourself with anyone else to give us an answer.
I'd like to pair myself with Princess.
Sorry, who are you pairing yourself with?
Princess.
Okay, talk to each other.
What do you get, Princess?
I got 8x.
I think I'm gonna have to disagree with you there.
What did you get?
I got 5 minus 2x.
For which question?
Question 5.
We are doing number 4.
We are doing number 4.
Oh, shucks. I think I did the wrong question.
What did you get for number 4, my brother, since we are on number 5? What did you get for number 4?
I got 8x.
What?
8x.
Are you sure?
Yes, I'm sure, sir.
And then you said for number 5 you got?
5 minus 2x.
Okay. Okay. Now, it's Alvin here. You are welcome. We'll keep you on the floor. Now, please talk to. Oh, is you and Princess on number 4?
Yes, sir.
Yes. What did you? Do you agree on with Princess on what you are telling us?
I agree with her.
Yes, we agree with each other.
Are you?
Yes, sir.
We do.
Okay. Thank you. Now, Elvin, for number 5, how many minutes should we give them?
I'd like to give everyone 2 minutes for this one.
Okay, then Elvin is your 10. Okay, it's 2 minutes. I'm counting the 2 minutes from now. Then it's going to be your 10 with any other person except Princess.
Understood, sir.
Okay, thank you.
Lerato.
Thank you, Lorado.
Dumeso.
Usiso.
Usiso. Who? People, can you? There is someone who's talking very, very softly from far away. Can you hear him or her?
So now we're on question what, sir?
Number 5.
Sir.
Okay, number 4. We all
Please,
agree
hang
that
on.
it's 8x.
It's
Hang on,
alpha.
alpha. What was alpha saying? Or is alpha done? Lerato?
Alpha. It's alpha.
Dalva.
Yes.
Lerato,
Sir.
I can hear you clearly. Ne?
Yes.
Let me make this request. Through you, please ask Dalva to speak a bit louder.
Dalva.
Can you hear me now?
Yeah, it's better. Like,
Please tell her to climb the table.
they're saying climb the table.
Hi, sir. Can you hear me?
Dalva.
Yes, sir.
Yes, how are you?
I'm good, and how is you, sir?
Good. Are you done?
Yes, I am.
Okay. Now, Alvin, now I'm pairing you with Dalva. Please talk to Dalva.
All right, Dalva, what did you get?
I got 5 minus 2x.
Okay. Which is what I also got, so I think we agree on that one.
Please talk to them.
So, Dalva, do you agree?
Yes. I don't know about the others.
All right, does everyone else have that answer?
Yes, we agree.
For
with
number
you.
5.
Yes, for number 5.
Yes, 5 minus 2x. I've got that.
Okay, thank you, Dalva and Alvin. Now, Dumiso.
Yes, sir. Yes, sir.
For number 6, my brother, how many minutes should we give them?
I think 4 minutes will be sufficient.
Sorry?
4 minutes.
4 minutes for number 6.
Yes, sir.
Okay. You all have 4 minutes according to what Ndomiso instructed us.
Sir.
Yes, who's talking?
Lerato,
Yes, Lerato. Are you done?
can you zoom in? Number 9,
Oh,
can you zoom in?
okay, let me capture your name here. Lerato.
Ndumiso's
It's
done.
finished. Sorry? Ndumiso.
Yes, sir. Ndumiso's done.
Okay, thank you, Ndumiso. Let's wait for 2 or 3. 1 or 2 more people.
Vincent,
Thank you, Vincent. One last person.
Busiso.
Sbusiso. Sbusiso, these 2 sisters of mine, Tando and Princess, where are they hiding?
Tando, where are you hiding?
We are writing, say.
Okay, I'm around. So
Are you
Yeah,
finished?
around. See.
yeah.
No. There is this word. There are these 2 words. Sbusiso, have you ever heard of them? But I think you heard about them. Stray animals.
Which words?
Stray animals.
I've heard of the words.
Yeah, no.
Yeah,
That person who said, no, we are around, now reminded me of these 2 words. So I just don't want people to be
Yeah.
around.
Hey.
We need them to participate. Tando, are you finished? Princess, are you finished?
Yes, sir.
Are you
So I'm
finished,
also
Princess?
done.
Done.
Theo is also finished. Okay, now, where should I go? Theo,
Yes, sir.
please pair yourself with any other person for an answer to number 6.
Oh wow, the honors mine today. I'll pick Ndumiso.
Okay.
Yeah.
I got
We are listening.
1 over. Sorry.
We are listening.
Oh, okay, sir. I got 1 over x square rooted.
1 over
X square rooted.
1 over the square root of 1 over the square root of x squared.
No, so 1 over radical sine x.
No, Miso, please don't trick me. What are you saying? What should I write? Please tell me what to write.
In the numerator, I have 1, sir.
Yes, thank you.
And then in the denominator, I have x square rooted. The
X
square root of
squared.
x. No, sir.
You have got the square root of x squared.
No, sir. I have 1 over. Then we put the radical sign, and then underneath the radical sign, x.
Okay, then please talk to
So
Theo.
1 over square root of x.
Okay.
Theo, what did you get, sir?
I got 1 over the square root of 2x.
Oh, yeah, so it's supposed to be 2x, sorry, not just x, 2x.
Yes.
2x, yes.
1 over the square root of 2x. Yes.
Yes.
Thank you, sir.
Is it what the 2 of you are telling us?
Yes, sir, it is indeed.
Yes, sir. Yes, sir.
1 over the square root of 2x.
Correct.
Yes, sir.
I'll just assume, no, it is no longer an assumption. Now, that's what you told me. Please talk to them.
Ladies and gentlemen, please comment.
May I get 2 over 2 root of 2x?
Yes, that's
But
the
I
correct
think
answer.
it's the same
So
as 1. Yeah.
yes, same answer.
1 over the square root of 2x, ne?
Yes, sir. It's the same
Yeah.
answer. Thank you.
What?
Yes,
Are we
Larato.
talking number 6, guys? Is it number 6, just to confirm?
No, Mr. Abdul, we're talking number 5. Yes, number 6. Sorry, number 6. Yes, sorry, yes, number 6.
What's
Number
the
6
answer
mean
for
I got
number 6?
something different.
It's 1 over the square root of 2x.
2x, yeah.
I got something very
I
different.
disagree.
Very,
I got 1 over 4 root 2x.
You got 1 over 4 root 2x.
Mine is different also.
Tando, what did you get?
Hello.
Hi, Tando, what did you get?
Okay, I got 1 over 2 root of 2x.
No, they're correct. Sorry. It's 1 over 2 root 2x. Correct.
Yeah.
Yes, it's correct.
and I got 2 all over 2 root 2x.
Narato,
So
yes, that's the same answer as 1 over 2. That's the same answer as 1 over square root of 2x because the twos cancel. Think about it that way.
ask
Yes.
Busiso first.
Yeah, it's 1
I
over
agree.
2x.
So oh wow.
Beyond me, so what are we saying? Is there an agreement or a disagreement?
I say it's 1 over square root of 2x, or it can also be 2 over 2 times square root of 2x. It's the same thing.
Yeah.
I
Ours is
agree
just
with you.
simplified
I
further.
agree with you. I agree.
Yes.
Ours is just simplified further.
Yes, same answer, just simplified further.
Do they agree?
Yes,
Family?
we agree.
Yes, I agree. That's what I
Yes.
got. I agree.
Okay. Thank you, Theo. Thank you, Ndumiso.
Thank you,
And thank you,
family.
everybody, for getting involved in the process of solving this exercise. Now, Lerato,
Sir,
how many minutes should we give them for number 7?
2 half, 1 half.
What,
Can you
Lerato?
get 3 minutes?
2 minutes.
2 minutes.
Yes.
Okay, everybody, you have got 2 minutes from Lerato for number 7.
Sir,
Yes.
when you are adding
Thank you. Let me
fractions,
capture Ndumiso first. Yes, Ndumiso. Then Lerato, I'm listening now.
when you're adding fractions, the lowest common denominator, you multiply it to the entire expression.
For me to can be able to answer you appropriately, my brother, give me those fractions so that I can go through those fractions
Okay, sir.
with you.
Let's say the expression it's 2 plus 3 plus 1 over 4 minus 2
hang on, 2 plus
3
plus 3
plus 1 over 4
plus 1 over 4
minus 5
minus 5
plus 1 over 2.
plus 1 over 2.
Yes, that's the entire expression.
Is that all?
Yes, that's all.
Okay. 2 plus 3 is 5, ne?
Yes.
We have got the minus 5 there. So the plus 5 and the minus 5 will cancel out each other. Do we agree on that one?
Yes, I agree.
Now we are left with 1 over 4 plus 1 over 2. Do we agree?
Yes, I agree.
Our LCM is 4. We'll have a division line below that division line, then we'll have a 4, okay?
Yes.
We'll say 4 into 4 is 1. 1 times 1 in the
Yeah.
numerator is 1. Okay. Lerato, are you with me?
Yes, I'm with you, sir.
Then we'll have a plus sign in between since we've got a positive sign between these fractions. Okay.
Yes.
Then we'll say 2 into 4 goes how many times?
2 times.
And then 2 times 1 in the numerator. What is it?
It's 2.
It's 2. So we'll write that 2 there.
Yeah.
So in the numerator, we'll end up having 3 over 4. That will be our answer.
Okay.
Is it making sense?
Yes, it makes sense.
Thank you. The 2 minutes is over. Now, let me check. Tando. Tando,
Hello, sir.
please pair yourself with anyone. Who are you pairing yourself with?
Princess.
Princess. Okay. Please,
Hello.
as you have already paired yourself with Princess, please talk to Princess and give us an answer.
Princess, you can go first.
I got 1 over 2 square root of x minus 6.
Yes, I agree with you.
1 over
2 square root of x minus 6.
1 over 2 square root of what? 6.
Square root of x minus 6. I don't know where the microphone is. Hello?
We
Princess,
can hear you.
Yes, sir. I said I got 1 over 2 square root of x minus 6.
please talk to your sister, Tando.
Tando,
Hello, Princess.
you agree?
Yes, yes. And you mean
Okay.
2, then under the root sign, it's x minus 6.
Yes, yes, that's the one.
Okay. I got this.
Sir,
Yes, Lerato.
like there's something small I wanted to ask before I disagree or agree. Root x plus root x minus 6. I don't know how they did it, but my answer, I got 2 root x and then the minus, and then I then said root 6. Is it still fine that way or?
You said, oh, hang on, Lerato.
Instead,
Yeah. Hang on. The 2 sisters are still with us on the floor. But now, I'm not taking their space. Let me just quickly look at what you just told me. You said the square root of x plus the square root of x minus 6. Ne?
yes.
Is that 6? Minus 6.
Original.
This minus 6 is just minus 6 over there. Ne? Or is it? Lerato. Is square root of x.
Plus square root of x minus 6 under the same thing.
Under the same square root sign, we have got x minus 6.
Yes.
Lerato, are you saying to me you have got the square root of x plus the square root of x minus 6?
Yes.
Thank you. I got that one. Then the 2 sisters will help. Okay. Whoa, Lerato. Before they help, let them talk to everybody, including you, about their answer.
Okay, it's fine.
Go ahead, Princess.
Tando, I was about to give you a 4. Do you guys agree?
I agree.
We've got 1 in agreement,
I
2,
agree.
3,
I agree.
4,
I agree too.
5.
They all seem to agree, Princess, ne?
Okay, perfect.
No, not perfect. Ask them whether there is anyone who disagrees before we can say perfect.
Okay. Is there anyone who disagrees?
Like it's not disagreement. Like ish. What was their answer again? 1 over 2
1 over 2.
over uh-huh.
In the square root, there is x minus 6.
I say I disagree with the format of how it's written. Yeah.
Okay. How would you write it?
It's 1 all over 2 square root of x minus, and then you write another square root of 6.
I disagree with you, Lerato.
What did you separate
I
them?
also disagree.
Because the law says you separate them.
Slow.
No, that's one expression under
Law
the
of
square root,
sets.
Lerato.
Law of sets.
It's one expression.
But this is the f of x we were given.
Yes. So that whole expression under the square root is one thing. It's just that we don't know what x is. So let's say, for example, x was 10. You're going to say 10 minus 6 is 4. Then the square root of 4 will give you 2. You can't separate and say square root of 10, square root of 6.
If x was 2.
If x was 2, you can't have a negative square root. But in this case, you're going to say 2 minus 6 is negative 4. And then you're going to find the square root of negative 4, which is imaginary numbers, something else.
You can't do that without doing complex numbers. That's why I'm saying we separate them to avoid that.
You can't, because it's one thing under the expression.
I hear you talking about the law of sets.
I don't agree with the format. That's the only thing I disagree, the format of the answer.
But we do the sets in 1501.
Yes, but the laws of set say you separate. Okay, so if let's say here in this case, it was square root of x plus, not plus, x plus square root of x times 6. You would separate.
Please say that again.
If it's square root of x plus square root of x times or divided by 6 under the set, you would separate them.
But we've been moving with this square root of x minus 6 from the get-go, isn't it?
Maybe that's how you do it. I've not been moving with it from the get-go.
You separated from the first step?
Yes, from the first step.
So when you separate, what do you get?
I get 1 over root x plus root x minus root 6. Root x plus root 6 plus root x is 2 root x minus root 6.
Yo, that's one that I don't wanna lie. I don't understand.
Can you please take us from the top? I think you
I'm
should
not
take us
with
from
it,
the
that
top.
one. But yeah, explain for us, please.
The answer is the same. Different is the format. So I wanted Seth to tell me whether the format I'm using, is it necessary or not? That's what I wanted to know. Is it necessary?
Lerato, my brother, in this case, let me choose to be quiet and ask them to lead you, because at the end of the day, I'm going to follow what they are going to say to you.
Okay. No, sir, I followed
already had them. I already had them.
You said
I already had them, but I just don't follow the point of disagreement with them. I don't know whether am I making sense or not?
You're making sense. but then it's fine. The answer is 1 over 2 root x minus 6. It's fine like that.
But yours was what? 1 over 2 root x minus root x
Minus root 6.
minus root 6. Is the root 6 under a fraction or it's by itself
Under the fraction
under the 1?
is it's the same thing, different format. That's all. I
Okay,
don't know.
let me see.
So if I hear you right, so let's say under that square root, the bigger square root, you'll have x minus the square root of 6.
Yeah, if you like, it's not a bigger square root.
How many square roots do you have in the denominator?
I have two terms which have square roots.
And okay, what are those two terms? What's separating? Are they multiplying? What's going on? Can you clarify that as well?
It's 2 square root of x plus, no minus, man, there it's minus root x.
Minus, so 2 square root of x minus root x.
Minus x, man, ish.
Minus x.
Yeah.
Not minus 6.
Minus 6, man, ish.
Hey, Lerato, this one I'm not sure, my brother. But the way you
But
are
then-
fetching it.
I'm trying to apply your way of doing things in my mind, and I'm talking at the same time. So I see something, but I'm thinking what Mats also said, what Princess said. So like it's mixed up. But then it's fine. I understand the 2x. I agree with the 2x minus 6. I have no problem with it.
So let's say now you are in that exam setup and then you get this question again. What approach are you going to use to answer this question?
Which one?
The same question, number 7.
Yeah, no, the thing is about approach, Ane. That's why I said I'm asking Sir, and Sir said you should guide me. Because now seems like everyone is agreeing that it's 2 square root of x minus 6. I'll agree. I agree with the answer. Column is
Sharp.
format.
You need to understand as well. That's another thing. Agreeing with the answer and understanding it, it's two different parts. So if I agree, I understand I hear that part. What about the understanding part of things now to say, do you understand how it got to that?
Matsus, Ane, my answer before I started applying the root of set, it was 1 all over root x plus root x minus 6.
Did you use the conjugate?
Before I used the conjugate and everything, made
It's
sure the
what?
a is equal to 0.
It was
It was
1 over?
root x plus root x minus 6. After cancelling out the 2, the what, there's a lot of cancelling out here.
Okay.
And then from
Okay.
there, I wanted to add root x with root x. But I remember there's a minus 6. We don't know the value of x. That's why I separated them. We don't know the value of x.
Okay.
If x was 2, root 2 plus root 2 minus 6. That's what I see it like that. I would have still separated them. And root 2 minus root of x. That's how they've rooted it. That's how they've down.
Sorry, Lerato, you said you separated
X. I separated
x
it.
minus 6. How? Because if you
Laws of
square x,
laws of sets, you can separate sets and match them up.
I think it's better if you take us through your question from f of x. Your answer, I mean.
The answer is f of x equals to number 7, Ane.
Yeah.
Square root of x plus h minus 6 minus square root of x minus 6 all over h times square root of x plus h minus 6 plus square root of x plus h all over each other. That's the multiplication thing. And then I multiplied, and then I got x plus h minus 6 minus x minus 6 plus 6 minus x plus 6. And then I got h times square root of x plus h minus 6 plus square root of x plus h. X cancel, 6 cancel. I'm left with the capital letter H in the numerator. Cancel the bottom H. I got 1. 1 all over square root of x plus h minus 6 plus x plus h. H substituted in the 0. 1 all over square root of x minus 6 plus square root of x. And then that's when I separated. And then from there, at square root of x minus 6 plus square root of x, I separated the two, and I did square root of x minus square root of x plus, no, square root of x minus square root of 6 plus square root of x. I added the square root of x's because they are the same, and then I got 2 square root of x minus square root of 6. That's how I did it. Everything's the same until we reach that point of 1 over x square root of x minus 6 plus square root of x.
I think it's your
Okay.
separation there, Lerato, because I've never heard, I don't understand how you separated x minus 6.
That's why I'm asking,
Because
sir. There's no such law.
Yeah, I
Lerato,
think
I've never heard of that
Lerato,
law. That's why.
Lerato,
Okay.
my brother. The square root of x minus 6. You separated it into the square root of x minus the square root of 6.
Yes, sir.
No.
Okay, it's fine then.
That's
I
what,
agree.
in simple terms, that is what I just needed you to hear it from them.
No, sir, they couldn't say no, it's wrong. If I say this is the law and it's not the law, say no, it's wrong. It's fine. There's nothing wrong with that. I say it every time. People should be
Your
able to say
approach, your approach, and I said to you, Rato, you can't separate. I remember saying, let's say we were to
Can't.
substitute
You
10. I
cannot.
said, whatever is under the square root is one term. You can't separate it. I remember saying that to you.
Yes,
So
you
that's
said
where I
it.
was like, substitute 10 for x. Then you're going to have 10 minus 6 is 4. Then you could find the square root of 4. You can't
Let's see.
separate and say square root of 10 minus square root of 6. It won't give you the same thing.
Say, when you
and when
speak,
Yeah.
when
it seems like people are afraid. I don't know what they're afraid of.
no,
I'm sorry.
we, we are not
Eh,
afraid. We want to
Lerato,
understand.
No, like
okay,
when I
go
say,
ahead, Princess.
We
when I
just
say,
wanted to understand where the error happened. If when you first substituted, ne,
Mhm.
after your first principle there, did you say square root of x plus h minus 6 in everything inside the square root?
our working is the same until 1 all, like I changed it when I reached 1 all over square root of x minus 6 plus square root of x. That's when I separated the two.
You can't.
Yeah, Lerato, I don't think there's a law like that, my brother. That's why.
Did you?
Because
Yeah.
I think it was Elvin who was saying it's one term underneath there.
It's
So
like
you can't separate it like that.
when you say
Lerato, sorry, Lerato. Without being afraid, I think I heard you, but then I just didn't want to come in before others, before I could actually make sure that others followed what you were saying. That's why I said, let me give them an opportunity to raise their view.
yes, sir. Okay, sir.
Mm.
Like don't be afraid to speak. When I do something wrong, say that it's wrong.
Yeah, but I did say the law of sets is for
Don't
what is
say
it? Cos 1501.
or on the complex numbers they do what.
Yeah.
Like when you say it like you mean it, man. It doesn't exist.
You know one other thing, Lerato, about maths, you can take a different route and get to the same answer. So sometimes it's not easy to say, Lerato, you are wrong. It only becomes easy when you get to a wrong answer, then we'll say whatever route you took was wrong because of we don't get to the same answer.
Okay, look, and
We'll work it like
in this workshop, When you speak to me, when I come to this workshop, I come like I know nothing, even if I start on my own time. When you speak to me like I know nothing. Lerato, it's wrong. Where is it wrong? I'll ask, and then you tell me. Done.
Okay. Okay. Hi, fair enough. We hear you. We hear you.
Thank you, brother. Thank you, brother. Point taken.
Yes, Talva. I think it's Talva.
Yeah, can I ask you a question?
Yes.
Let's say maybe you were given, let's say on the numerator name, it was something like 1 plus square root of x, right?
Yes.
Then on the denominator, you have that x minus, is it x minus, you have the square root of x minus 6. We're going to separate the denominator.
Yes, I was going to do it because I thought it was allowed to be done. It was fine to do it.
But it was not going to give you the correct answer.
Yes, I know it was not going to give me the correct answer.
Because that one at the bottom is like 110. And then now on the numerator will be like we are having like 2 terms. I don't know if maybe you are getting what I'm trying to say.
I understand what you're trying to say.
Okay.
Is it clear, Lerato?
Yes, it's clear.
Thank you, brother. That's why I usually say, I don't know these things that you people are doing. All of you, I don't know these things that you are doing. I just came here to learn as well. So, Lerato, I welcome and really appreciate your words of saying we need to say it upfront that something is not supposed to be done the way it's being done. Remember, in my vocabulary, I'm not having that word. So thank you for opening up. Let it be for everybody. Let it be for everybody. That's why when you threw this question at me, I threw it at everybody. But then this is part of learning. We are all here to learn. The intention is not to discourage each other, but to learn from each other. Are we all still happy?
Yes, we are happy.
Remember those two people who gave us an answer? Who were they?
It was Princess and Tando.
Princess.
So, Princess and Tando, except what Lerato raised, it looks like almost everybody agreed with you, né?
Yes, sir.
Lerato, what you had as a challenge has been clarified, né?
Yes, sir. It's clarified.
Thank you, brother. Let me request you to go and look at number 8, number 9, and number 10. Abdul, remember homework. Yeah? Let's treat 8, 9, and 10 as homework. Tomorrow we'll start by verifying the answers to these 3 before we continue. Is that okay?